Welcome once again to our online classes, and today's class we are going to focus on Miller indices of directions. Within a crystal lattice, we can decide to show the orientation of a plane or a direction within a crystal lattice. And the technique that we can use to show that is by writing its Miller indices or the Miller notation. Meaning that in today's class, for instance, our focus is on the directions. It means that you are given the direction within a lattice or within a unit cell, and then you are required to show the Miller indices. Now, if this is the cell that we have, for example, most of the time we'll require ourselves to start from the origin because we need to show where are we starting, which is the origin, and where are we ending. So the first thing you need to do is to choose the origin. So if, let's say, for example, this is our origin, so this is the origin, and once we have notified our origin, or once we have identified our origin, then we need to choose a coordinate system. We have only 3 coordinate systems, and from here going to the right we can have our y, and coming towards me we have our x, and going upward we have our z. Now you notice that when we go to the right we have positive y, and therefore if it happens that you are going to the left, then you are going to have minus y. So everything that moves to the left of the origin in the y-axis will be minus y. And therefore, if we decide to go, everything coming towards me is positive x. And therefore, everything that's gonna go away on the other side of x is going to be minus x. If it goes upwards in the positive z direction, then it means whatever comes down below the z or in the below z direction, then it's going to be minus z. So this is very important for you as a learner to know exactly the coordinates that you're working with. Most of the time, or at all time, we'll try to show the coordinates or our direction to be within the plane. For example, if this is our origin, let's choose this corner as our origin, and therefore this direction is our positive x, and this direction is our positive y. So positive y, positive x, and the one going upward is our positive z. So this is our positive z. So we are saying that if therefore I move towards this direction, this is my minus y, and if I move to the other direction, then that is minus x, and therefore if I come towards this direction, then this is minus z. This point of origin can be any point within these corners, so long as it is going to give you the right direction. What we normally try by all means is that we have to try and draw our direction or show our direction to the point that it moves within this cell, not outside. For example, if I have minus z or minus y or minus x. So for example, if I have, let's say, minus y, so remember we have x, y, and z. So if I have minus y, then I'll rather move towards this direction, meaning that this can be my origin, so that my minus y go towards this direction, or my minus y go towards this direction, or this direction, or if this is my point, then minus y will be this. But I cannot choose this point, or this point, or this point, or up here, and I have my minus y going towards this direction. No, it will be more difficult to draw because we want by all means our negatives to be within the cell. Having said that, once you have chosen your coordinate system, then you need to find the coordinates of the directions. So that simply means that if I start from this origin and then I move towards this point, this is a full length and that is 1. And if I move towards this point until this corner, that is positive y and that is positive 1. and then it happens also I move towards this, and that will be my positive z, positive 1 in the z direction. Sometimes it can be half, and that's gonna be positive half, or sometimes if it's, let's say, coming down this way, that can be minus half z, or if it's going towards this direction, let's say this direction, because this is x, and because it's going behind x, if this is our origin and it reaches somewhere here, then this is minus 1 over 2x. So those are what we mean by find the coordinates of the directions. Then it reaches a certain point that you have the halves, or it can be half or 1/3 or 2/3 of the full length. Not all the times you're going to have the full length, like in this case whereby we have 1 1 1. Let's say going this point, this is full length. Sometimes we'll have 1 1 1 or full length, and sometimes we may not have full length. So in case whereby, let's say we move from this point as our origin and we move in the minus half direction, let's say at this point, which is going to give us, let's say, minus 1 over 2. You can see this is a fraction. At certain point, you may end up yourself having fractions like minus 1, and then you have a full length and also a full length. In this case, you realize that you have the fractions. So if you have a fractions, we try by all means to reduce the fractions to the lowest integer. And in case of a fraction, we are going to multiply by the common factor to eliminate the fractions. So remember, this applies when we're looking for the directions. So don't confuse them with the directions and the planes. For the one of the planes, we are going to see. So if you have a fractions, in case of directions, we are going to multiply by the common factor. And the common factor here is 2. So if you multiply both sides by 2, then you are going to have minus 1, and you are going to have 2, and you are going to have 2. And then we close it. In terms of the directions, then we need to use the square brackets. So for example, we have minus 1, 2, and 2. So this one will come as, when it comes to minus, we write them as a bar. So we're going to have bar 1, and then you are going to have 2, 2, and we close it. So for example, let's look at A. So I've already drawn them for the sake of time and showed the directions. So let's assume that in this case we have our origin and we have the tip. So this thing is moving from this point, so we choose this our origin, and then it moves towards the tip. So it means that our x, y, and z meet at this point. So we choose our coordinates. So this is going to be our y, and this is going to be our z, and this is going to be our x. So it looks like this. So we have our x, sorry, this is y, and this is our z. So this is how it looks like. So this is our origin, and this is the tip. So at the end of the day, everything must go to the tip. So it therefore means for me to reach here, if this is my origin, then I must have moved one full length on the positive x, and then I move one full length to the positive y, and I move one full length to the positive z, and that is when I can have this one at the tip here, this direction. Because if I move, let's say I move towards this point, and I move, let's say I move towards this point, and I move this point and come this point, it doesn't make sense. So it means that our x, y, and z, our x, there is one full length on the x-axis, and one full length in the y-axis, and one full length in the positive z-axis one, and therefore after writing this is to the lowest integer because it's 1 1. We can then write them in the bracket. So we close them in the bracket, and this become our Miller index for A. Let's look for B. In B, the tip ends here, and this is our origin because this is where it begins. So from origin, we can have to choose our origin, this point, and after that, remember, we wrote the coordinate system, so our y, and this is our x, and this is our z. So now for me to come to this point, remember, this point is x, and this point is x, this point is y, and this point is y. So I cannot come this point, move this and move this. No, it is impossible. It looks possible though, but it doesn't. The only possible route I can take is to move towards this direction, and this is at the half of the center, so I can move to half, I can go, and remember it is half on the minus side, so I'm going to have half x and y. Then from here I move to negative y full length, so y is full length. And then when I reach at this point, I realize that I have not gone to any z system. In z direction, I haven't moved, so it is 0. So this is what we have. We said that when you have a fraction, you multiply by the lowest, by the common factor, if I may say that. And the common factor here is 2, so we are going to multiply by 2, and this is going to give us minus 1, minus 2, and 0. Okay. Once we have this, then we can write everything minus as the bar, and we close the bracket, and then this one will be as bar 1, bar 2, and 0. So this is the Miller index for B. Let's look for C. So this is the direction. So it moves from this point, so until this is the tip. So everything must meet at the tip, and therefore this is our origin. This is our origin. So once we have our origin, we have z, we have our y, and we have our x. Okay. So for us to reach at this point, still I can move in the positive y, and then I come in the negative, in the positive x, and then I move to the negative y, and then z is equal to 0. So in this case, I have my x, I have my y, and I have my z, and I have moved in the positive x. So I have moved in the positive 1/2, and then in the y, I've moved towards the left because this is my origin. So I have moved to minus 1 full length, and z is equal to 0. Just like we did for B, we are going to multiply by 2 because it is the common factor to eliminate the fraction, and we are going to have 1 minus 2, 0, and then we can have it and close the bracket, and we have 1, but 2, and 0. So if you look, in this case, it is almost like B. C and B are almost similar, but the difference is the direction. Okay. So let's look at D. So if you look at D, look, this is the tip. So if this is our origin, so we're going to have our x, y, and z. So this is our origin, and we say once we choose the origin, write the coordinate system, and therefore this is going to be my z, and this is going to be my y, and this is going to be my x. I've chosen. Step 2, then we write the coordinates. So if you look, this is half point, so I'm going to have half x, and it means that these things move in this direction. It reaches until half x positive, and then it moves to full length in the minus y direction. Once it reaches here, then it moves downward in the z direction. So our x is positive 1/2, positive half, and then it went to the minus direction, minus y, full length, I have minus 1, and in the z, because z going upward is the positive direction, so when it goes downward is the negative direction, and it is half, so we have 1/2 in the z direction. So once we have written this, we multiply by 2 because of the fractions. To eliminate fractions, we multiply by 2, and then we're gonna have here, we're gonna have 1, and we're going to have minus 2, and then we're going to have minus 1, and then from here we can write it in bracket. So we have 1 minus 2. We said everything minus become bar 2, and we get bar 1. So this is the Miller indices or Miller notation of this diagram D. So it comes this point, it moves towards this full length, and then it moves here. I hope you can now do E and F. Pause the video and try E and F. Now for E, the first thing we have to write our X, Y, and Z. Now look where the journey begins. It begins at this point, and therefore this is our origin, and we said once we have done that, we write our coordinates. So this is X and this is our Y, and going upward is our Z. So you realize that the direction travel one full length in the Z direction, but it is downward of the origin. So therefore it's going to be minus Z direction. But it did not move any inch on the y-axis, neither did it move on the x-axis. So x and y-axis, there was no movement, and therefore it became our 0x, yx, but minus 1 in the z direction. And once we have written this, the least integer here is minus 1, is 1, so we don't need to multiply by anything, so we can write this in our bracket. So 0, 0, minus 1. Sorry, or bar 1. So that is for our E. I hope you get that right after pausing the video. Let's do at F. Now look at F. This F starts from this point, and therefore this is our origin, and it ends here. This is the tip. So if this is our origin, then this become our X, this become our Y coordinate, and this is our Z. So for me to come to this tip here, I cannot move this way, I'm going to miss this point. So the only direction I can take to reach at this point is that if I move towards this point, I move towards this point and take towards this point, and then I reach here. That's the only direction that I can do. Now, having said that, this is halfway x, but it's in the positive x, so I'm gonna have in my x, y, and z, I'm going to have half x, and in the y it moves minus y full length, so I'm going to have minus 1, and in z it moved one length in the opposite, in the upward direction, which is positive z, and therefore this is our full length 1. So 2 is the common factor. We're going to multiply by 2, and that's going to give us, when we close the bracket because of the space, it's going to give us 1, and minus 1 times 2 is going to give us but 2, and 1 times 2 is going to give us 2. So this is the notation for this part. So let's continue and look in the next slide. So you can pause the video and try G, H, I until K and C. So let's look at our G. So this is where we begin from, and we end at this point. So this is our T. So this tells us that the only possible direction I could have taken to reach here is either I go this way and move this way. It's the same as moving this way and this way. So in this case, we have our X, Y, and Z. So if you check, I moved, I'll take this direction. So it's going to give us the same, but because of this is y, so it's in the positive y, so I have positive y. But because this is our origin, so this is our x, this is our y, and this is our z. We did not move in any z, so our z is 0. And in the x, we moved minus x, but 1 full length. So it's going to give us minus 1. So we write the bracket, we close the bracket, and this is going to give us bar 1, 1, and 0. So this is the Miller indices for this G. And let's look at this H. Pause the video and try H. So for me to reach at this tip, ladies and gentlemen, I must have either moved towards this direction, 1 full y length, 1 full x length, and 1 full z. Okay, or I might have moved in this direction and move this direction and move here. So I'll choose any. So we have our x, y, and z. So I have moved 1 full length. So this is our origin, remember. So this is our x, and this is our y, and this is our z. So I have moved minus 1. I've moved 1 full length in the minus x direction because I'm going backward. And reaching this point, I've moved 1 full length in the y direction, in the positive y, so 1. And also I've moved 1 direction to the positive z, and that is 1. So I can close the bracket and write bar 1, 1, 1. So this is the notation for H. Let's look at I. Let's look like me, the I cell. So this is the point of origin, and this is the tip. Okay, this is the origin and this is the tip. So if this is the origin, then this is our positive x, this is our positive y, and this is our positive z. So for me to reach at this point, I must have moved at this point minus 1 in the x direction, and I've moved in the positive z direction. Remember, this is x, this is z, this is y, this is y. So by look of things, we have not moved to any y directions, and therefore our y is 0. So if this is my x, y, and z, so our x, we have moved in the minus x direction, we have full length, and we have moved in the y direction 0, and in the z we have moved 1 full length, and it is in the positive. So this is what we have, and we can write it as bar 1, 0, and 1. So this is the Miller index or Miller notation of cell I. Let's look at J. So this is our point of origin, and it ends in the half of Z. So this is the tip. So for me to reach at that point is either I have moved in this direction 1 full length in the minus x, and then 1 full length in the minus y, and half. This is okay, is this point is half in the z direction. So it means this is our origin, and once you have chosen our origin, let me adjust the ink. So this is our origin, so this is y, this is z, and this is x. So having said that, then this is the same as still moving like this, moving this, and reaching here. It still is going, no matter where you choose either this or this, it's going to give you the same. So let's say this is our x, y, and z. So I have moved 1 full length in the minus y because this is my origin and I'm going at the back. So this is minus 1, and I've moved 1 full length in the minus y. So that is 1, because from this direction to here is full length 1. And in the z, I have moved 1 sorry, a half, but it's in the positive, so I'm going to put a half. There's a fraction and the common factor here is 2, so we can multiply by 2, and that's going to give us minus 2, and 1. So once we have this, we can write it in the bracket, close the bracket, and that is bar 2, and this is going to give us bar 2, and 1 is going to be 1, and that's what we have. Finally, let's look at k. So if you look at k, this is where all begins. The journey begins here. This is the birth of k. So this is our origin. So this means that this is our x, and this is our y, and this is our z. So for me to reach at this point, I cannot move this, no. The only possible direction I can take in this case is to move through, let me show, is to come one full length in the positive x and half length in the minus y. And in this case, you realize that we don't have z. So if I have my x, so I'm doing it here so that it doesn't confuse with the other one. So I have my x, y, and z. So my x have moved one full length in the x positive, and half y in the minus, because we are going the other side, and then in the z we have 0. So the common factor here is 2, and that's going to give us, we multiply everything by 2, it's going to give us 2 minus 1 and 0. And when we close the bracket, this one is going to give us 2 by 1 and 0. So ladies and gentlemen, this is how we can show the indices or the Miller notations of the directions. The first thing that you need to do is to choose the origin and indicate the coordinate system and show the directions, and then reduce them to the lowest integers. If you have a fraction, then you need to multiply by the lowest. Remember, fractions can be even 1/3, it can be 2/3, it doesn't matter. But once you have the fractions, then you need to reduce them to the lowest integers by multiplying by the common factor. Ladies and gentlemen, thank you for watching, and hey, remember to subscribe and hit the notification bell so that when we upload such videos, then you can be notified. Remember to subscribe. Thank you so much. In our next class, we are going to see Miller indices or Miller notations for the planes, and how we can also use Miller indices to show directions and also to draw planes in our next video. Thank you so much for watching. Adios. Bye. Kwaheri.